Hello, students of Seneca. Today in this GCSE chemistry revision episode, I'm going to be telling you how to get pure. I'm going to be talking about purity and formulations. So let's dive in. A key thing to know about impurities, they are things that increase a sample's boiling point and increase the range of temperatures at which a sample will boil, okay? So what's a pure substance? A pure substance is a single element or compound that has exact and specific melting and boiling points. So pure water would have a boiling point of 100 degrees Celsius, for example. And impurities are things that will make a pure substance impure, hint is in the name, and it's going to mean that designated boiling point or melting point isn't so specific. Okay, let's go over some definitions now. So firstly, we're going to start with formulations. So formulations are mixtures of chemicals that are designed to create useful products. And in formulations, each component helps to decide what the mixture's overall properties are. To ensure that a formulation does what it's supposed to do, each chemical component has to be present in a precisely measured quantity. So the quantity of each component is really important in a formulation. So formulations are everywhere, right? So examples include cleaning agents, fuels, metal alloys, fertilizers, and medicines, okay? So those are some really key examples of formulations. Let's go over them again. Do you remember any? We have cleaning agents, medicines, fertilizers, metal alloys, and fuels, okay? So to ensure that a formulation does what it's supposed to do, each chemical component has to be precisely measured. So that's the quantity that's important. Now, do we remember what impurities do to the melting point of a sample? They reduce the sharpness of the melting point. And by sharpness, I mean the exact temperature at which something will melt. That's what an impurity is going to do. Right, now let's move on to some purification mechanisms. We're going to start with chromatography. Now, this is a process that separates a mixture into its different components. Importantly, it has two phases. Substances are picked up and carried by a mobile phase, so that's a liquid or a gas. And then the mobile phase moves to a stationary phase, which is solid or viscous liquid. Viscous means really thick, so like treacle. Separation of substances. So this depends on the distribution of a substance across the two phases. So a substance moves far if it's more attracted to the mobile phase, or a substance doesn't move far if it's more attracted to the stationary phase. Makes sense, right? Strength of attraction. Different components can sometimes be equally attracted to a solvent. Therefore, the number of spots a mixture produces can vary depending on the solvent used. Now, how many chromatography spots are produced by pure samples and why? Do you remember? So, the definition of a chemically pure substance is that consists of only a single element or compound. This means that pure samples will only ever produce one chromatography spot, regardless of solvent identity. Okay? So, what are those two stages of chromatography? We have the mobile phase, where the substance is picked up, and then the second phase is when the mobile phase moves through the stationary phase. Okay, little definition question. What do we call mixtures of chemical components that are designed to create useful products? Now that is a formulation, so stuff like medicines, metal alloys, all that stuff we talked about earlier. So what do impurities do in a sample? They can increase the boiling point, decrease the melting point, and they increase the range of temperatures at which a substance will melt or boil. So that's what we talk about when we say reducing the sharpness, okay? Now, in chromatography, substances are picked up and carried by a mobile phase, liquid or gas, which then moves through a stationary phase. And do you remember what that was? That's a solid or viscous liquid. So very quickly, let's just review some examples of formulations. We have medicines, fuels, fertilizers, cleaning agents, and metal alloys. So something like brass instruments. So if you're a trumpet player, boom, you like your formulations. Okay, so what are the two phases of chromatography? A mobile phase and a stationary phase, okay? And just to finish, two facts about formulations to take away with you into the big wide world. Every component of a formulation affects the overall properties. So every component is important, and the quantity of component is precisely measured because we want everything to be precise and great. So that brings us to the end of this revision episode. I hope it was useful. Keep up all your hard work and your revision, and good luck with your upcoming exams.